Yeah, well, at least it's working. Not working correctly. Improvements. Okay. Few things here. What was I doing? I was going to tile CS, and I was going to add in soil moisture. That's right. I'm going to need to do some major... Oh, hey, Isdar. You need to do some major tuning. But I think I got soil absorption working. That is right. Shoot. So part of the issue here is we shouldn't Oh, is the audio weird? Someone's giving water some suck. What's on the plate today? Is the audio weird for anyone else? Are you having a difficult time hearing me? Or are you hearing something in the background? Anyway, yeah, so what we're doing today is adding soil moisture. So we don't just want like plants to be drinking water from the sky or scooping it from a river. And so the idea is we're having primary water sources fill the soil with moisture depending on the soil texture. And so we have water infiltrating into the soil, and then we have water leaving the soil and entering the aquifer. And so we're simultaneously going to have, we're constructing the stabilizing force for ecosystems via soil moisture, but then also hopefully we should be able to generate sort of below groundwater reservoirs. And so sandy soils will have water that goes zoom straight through the soil and sort of into the aquifer, and so we should have different conditions based on soil conditions. Whereas basically soils that are able to hold on to water better are better able to have more biomass on the surface, which then is able to grab the water before it permeates through the soil and put it back into the atmosphere. Right? We just overcompensated a little bit initially, so we'll need to tune these values. And I need to re-enable the other jobs first. But I had a major bug that I had to deal with. So seasonal water flow, potential water flooding. So here's all of the new code in water flow. And so we're going to be taking most of the water calculations that we had bloating the vegetation model, and instead we're putting it into the water flow model. So as the water is flowing, we're deciding what goes into the soil, what stays on the surface, etc. But I just now got it to work. I was working on it last night. Just now got it to work, and so now I need to do all of the tuning and stuff like that. Because I had a bug last night where we were generating infinite water due to an undefined or division by zero issue. Okay, so re-enable glaciers, re-enable hydrology, re-enable soils, re-enable vegetation. Bloat relocation. Well, it should be more efficient too. The way we were doing water and vegetation was just all wrong. And I was resisting changing it because I knew it'd be a big job, but then I realized there was really no way around it because we needed monthly water flow to accurately represent vegetation patterns. Otherwise, we'd have sort of these permanent gallery forests along every single river. And we'd have to start doing all of this weird work when it came to trying to infer where floods would happen and landslides would happen. And then I realized there was a better way to handle water flow in general after we constructed water bodies. That would be 10 times more performance than what we had before. So that's when it became a practical option. So now I'm toying with the idea of monthly vegetation growth calculations. I don't know though. I don't know yet. Uh-oh, what's going on with the vegetation? Stuck at 0%. That seems wrong. I know it's wrong. Well, first off, I'm a little worried about these calculations. But it's not burst compiled at the moment, so that could be what's slowing us down. Whoa, okay. That's not supposed to happen. Could be another reason. So my guess is we're going to click here and it's going to be undefined. Yes, nan. Yeah, it's another Magi experiment gone wrong. Accidentally released some magical self-replicating automaton into the ocean. What are we doing wrong? If no ice is involved. Okay. Okay, I know what the problem is. Problem is, we are applying this. We are applying this calculation in a whole lot of places it shouldn't be. Like on water, where there's no soil. We also need to enable burst compiler. Where did we... That's weird. Hold on. Apply evaporation. I'm confused. Okay, let's put you back. Alright, so where were you declared? Potential water flowing. Oh, it was declared up here. Oh, shit. That's right. This is why I put all of these calculations here, because they were in the scope of this. Of course, the problem is... Don't we check for land, though? Tile, ice? I guess not. No, we only check for ice. See, I was under the impression that elevation lists... Oh, wait. I was under the impression that elevation list only... checked tiles that were land, but I guess not. Where were you defined? Static storage. That's not the definition. Where's the definition? Yeah, I guess it checks every tile. Oh, that's right, because technically we need it to rain on water bodies that aren't oceans, right? It rains on a lake. If it's a freshwater lake, it needs to continue draining. What's your favorite flavor of pizza? Plain, double cheese. My favorite ice cream is vanilla. I am the world's most boring person. cheese only. Yeah, don't contaminate the purity of my cheese pizza with sardines and pineapples and shit. Come on. This is annoying. I don't know how to do this easily. So, potential water flowing. Right, and I don't want to. Well, the sauce is okay. Just don't overdo it. You just gotta. Like, maybe what some of you people that aren't Americans don't understand is, like, Americans think that, like, cheese is like a food group. Everything is better with cheese. Cheese is a food group, see? The issue is we need to preserve what came from rain and what didn't. In theory, the lazy ass way to do it is to see if we used temp float 2. We did not, so we could just use a temporary variable here. Be lazy. Dude, why? Where's my cursor? How did I lose my cursor? You serious? Cursor gone. Who knows computers? How do I get my cursor back? Or my little cursor is here, but I can't see. Hold on. Okay. Okay, so it's an issue with the file. Alright, I'm gonna close you. Okay, so now we'll just store it on the tile for now. Hey, what are you complaining about? What? You're, oh, whoops. No, not a bool. Temp float. There we go. There we go. I just need to make sure that I properly reset that variable. Which I will do momentarily. And then we need to move all of this someplace else. Oops. Debbie made me order pizza with triple cheese. I like the way you think. My wife and I were younger, and in college, like, a romantic dinner was just like, we take a plate and like cut up blocks of cheese and then just like put it on the plate, microwave it, melt it. Mwah. Delicious. Those were the days. Just dispense of the rest of the pizza entirely, just go straight with cheese. Butter sandwiches. I knew a guy that ate sugar sandwiches. I kid you not. He'd just take, bleached granulated sugar. He would just dump it on bread and then eat it. It's like you could eat like a jelly sandwich, but just like skip the middleman. And crazy thing was, this guy was he was super skinny and like a smoker and had no sense of taste. He smoked so much, and he's always like, whatever, sugar sandwich. You'd like listen to him eat it, and he's like, crunch, crunch, crunch. Ugh. Alright, where do we want to move this? I'm trying to debating. I mean, it should be here in theory. Okay, let's see what that does for us. Yeah, we're gonna be screwed if we do not modify. Hey, Kala, are you there at the moment? I have a question. Where was... when we use this set data parallel job guy, do we just have to have another job for wiping out each variable involved? I'm assuming, because we're specifying the data and then the value, but yeah, set job. If you want to wipe multiple. Okay. Mm-hmm. Oh, right. That's actually a good idea. That way it's not taking up so much room. Yeah, I was just thinking that cow because it's going to get pretty redundant. Okay, let's give this a try. It's going to probably look a little crazy still, but... I should also test to see how long this water flow is going to take, because I've added in all of this other stuff. It's going to come out of vegetation, so it's not that big of a deal, but... it's not too bad. I thought that was a little odd. What is going on? Why are deserts loaded with water? Okay. This damn mage is at it again. Where did my seasonal water file go? Here we go. Okay. Nobody wrong this time. If no ice is involved, release water that all seasons. Okay. So then we went ahead and stuck temp float 2, which determines sort of water that is coming from rainfall. Why? So here's the thing. If areas like this are virtual deserts, what is it? Okay, and this is supposed to be a desert. So what that tells me is that in dry conditions... yeah, this is all supposed to be desert. In dry conditions, something odd is happening. So here we have... well, it's not that dry. It's definitely a desert, but... more of like a xeric desert, really. Bugs. Bugs never change. If land is false, we calculate capacity. Let me see if I accidentally borked soils. No, looks normal. Alright, that's not the problem, because I had messed with soils a little bit. Ooh, I know what might be happening. And I know how to test it. So we're going to see if the first run of this algorithm works. And if it does, then it's something that relates to soil being saturated. So So I think what might be happening is the soil's getting saturated with water after. What's happening is as we're running the water flow model, it's filling up the soil with water, and with no plants there that drink it, it's probably getting to the point where a lot of places just get totally saturated. And then I think something screwy with the calculations is going on. So what I'm going to do is I'm just going to go ahead and run just the first run of it. Nothing can get saturated by that point. And so then we'll see, like... See, but the thing is, our deserts then filling up. Because we've got sandy soil, so that the water just kind of goes through it quickly. And they're not getting much rainfall, which would seem to suggest that they wouldn't be filling up quickly. So, let's see. Okay, so on the first run, nothing's wrong. Everything's fine. Obviously need some tuning, but aside from that, not a big deal. Okay. So all of this code is running fine. So when is it going off the rails is what I wonder. We could try and log out a specific tile's... Yeah. Let's find a specific problem tile and then we'll log its variables, and then we'll see at what point it goes spiraling out of control. Alright, let's find a good candidate. What the fuck, dude? The grasses like it. Let's write down this tile ID somewhere. So, question is whether. Nah, it seems like every tile fitting this criteria is probably generating ludicrous amounts of water. So 5, 4, 1, 4, 0, 1. Alright, let's do this. If tile dot not is land ID equals 541401, then bitch load the blogs. I always forget Unity engine.debug, was it? Stuff and things. I thought that was how you're bitch. Just want a file with an example of Unity debug because I can never remember what it is. No. Fuck you. No. I know glacier formation has it. Oh, for fuck's sake. Unity engine.debug. Oh, .log. That's right. Here, I'm gonna build some muscle memory here. Dot. Oh, it was right there the whole time. I didn't even notice. Alright. Stuff and things. Okay. Acceptable. So. Capacity. There. Now let's log out like everything else. And also let's disable burst compiler. Log out soil moisture at that moment. Soil moisture. Saturation. Okay, so this is our infiltration multiplier. This is how much rain goes in. Rain in. Oops. much moving water ends up going in. We can infer this. You know what? I bet this is what. I bet you anything that this is where we're having an issue. Promise you. Because it was like 11 o'clock at night, and I was like, I gotta finish this. But I don't know. Let's see. If capacity not met, fill the capacity and then send remaining water on its way. Is that what we're actually doing? Wait a minute. Where's water out? Okay, the water that we're sending on its way. I mean, seems relatively straightforward. Here, let's do this. But wait a minute. Yes, this. No. That's wrong. That is wrong. No, this is not. So here so we're adding moving water in. Rain in is 10 float times infiltration. Why are we subtracting? Oh no. Right. We're adding tile temp float 2, which is the amount of rain that we would have, minus rain in, minus moving water in. No, yep, that's right. And the remaining goes to temp float, which is our moving water in tile, which then moves on to other tiles. By the way, I read today that the version of burst we use has logging fixed. Oh. You don't need to disable burst as long as you don't use string addition. So how do you avoid that? Oh wait, so would you do it by, for instance, having 2 consecutive logs, one that says capacity, colon, space, and then debug log capacity? Is that how it would work? So you just wouldn't concatenate here? Oh, right. Yeah, string substitution like in Python. Or yeah. I'm used to doing that in Python. But where do you specify... Yeah, I'll mess around with it in a bit. Just solve this immediate problem right in front of me. So the question is, if capacity not met, fill the capacity. Let's look at the check. So if total water added plus the current soil moisture is less than the total capacity of the soil, then we recalculate soil moisture, which is equal to the current soil moisture plus the rain that goes in, the moving water that goes in, and then we add the rainfall minus rain in minus moving water. Moving water in. That seems legit. But here we're over capacity, so we calculate this thing called amount added, which is the total capacity minus the current soil texture or soil moisture. Wait, what? I think this number is accurate. Let me see something. I think I know why this is happening in deserts. Hold on. Okay, before we do anything else, I've got an idea. Okay, thanks, Callum. Let's see. If we're not subtracting, let's see something. Okay. Made it, not full yet. Is full. Yeah, I think one of the issues here is we're not letting any water drain. Could have sworn we had calculated a factor for it, which is confusing to me. Hold on. So. I distinctly remember doing this calculation somewhere. Determined. No, we do. Water loss due to subsoil drainage. Yeah, so it's draining. It, yeah. Oops. Oops. I accidentally logged it. Yeah, it's gonna take forever. Oopsie daisy. I forgot that I needed to make it contingent on a specific tile ID. Oops, yeah, I accidentally terminated it mid-run, so I gotta start that over. I need a Köppen climate map on my wall. Why do I not have a Köppen climate map on my wall? I've got soil orders. I have biomes. I have water catchments. I have forestation maps. I have elevation maps. I do not have a Köppen climate map. They've actually been way more useful than I thought, because like you need to unfocus your eyes from like the screen, but when you have something like when you have all of these sort of geospatial maps on the wall, you become like really familiar with where everything's at related to everything else, and how your biomes overlap or intersect with your soil orders and catchments and stuff like that. So I could really use a Köppen climate map. I should make one and have one shipped to me. What I typically do is like there's some... Uh-oh, what's happening? What the fuck? This is because burst is disabled. Yeah, probably. I gotta use Cal's method. Well, I don't understand now. How many times did we run? Okay, so... thinning silts. Apparently we were just instantaneously full. WTF. Full. So that's... I guess that's part of the problem, right? I see. I see in terms of the logs I should be using. Alright, we'll actually save this for later. For now, why are we filling up so quickly? Alright, well, let's go ahead and log out the details. Re-enable burst. would be perfect. B. Soil orders, coping climate, biomes. Actually, you guys can probably see. What does that look like? And a few others back there. One day, I'm gonna have a super home office, just have like walls full of maps. It'd be glorious. Alright, let's see if we can use the Cala method here. Right, so all we really need to do is get rid of this dude and do our variable substitution. That should be right, I think. By the way, I have capacity a second time. Rain in. Oh, moving water in. No, moving water in. We have it right there. Alright, what are we missing? Moving water in. No, I don't need total water added. Oh, that's right. We needed. Do you have current saturation? No, let's just go with this for now. Okay. This should work. Actually, while we're generating, let's look into getting a nice Copen climate map. Did we re-enable burst? Yes, we did. Got plenty of choices. Something global, please. Something like this would be nice. Oh, that's fascinating. Interesting. Except I don't really believe it because I would expect there to be a lot more desertification. Okay, just give me present new global maps of the Copen climate classification. The present day, blah blah blah. Can you? The maps can be downloaded here. Thank you. I don't want future. I just want present. No! I tried to run 500 years of 500 years of vegetation. That's no. Hey. Science would never do that to me. Science would never. Figshare.com. That sounds credible, doesn't it? That sounds totally not shady. Alright, let's see. Unconfirmed download. Okay, I'm gonna go ahead and open that right now. Oh, be quiet, Windows. Be quiet. Sounds absolutely reputable. Damn it, no, where's the key? Ah. I took all that risk to download this, and you guys didn't even... Man. Is it on the wiki? Okay. Yeah, but that's not... No, I need it in the same file. Like, I just need a nice flat PNG or something like that, so I can print it out as a poster. Okay, I'm gonna crowdsource it. Can you guys go out and find a good candidate for me that looks like this, at high resolution, but also has the key. Memorize all the colors. See anyone volunteering? Fine. I will find. High resolution with key. Oh, here's a wiki version that I missed somehow. Looks weird though. Is this accurate? Something looks off. Well, okay, here we go again. Hey, it didn't work. Oh, did I not put the $sign? Crap. I don't think I logged it out properly. No, I did not use the $sign. Fuck. I think it was that? Yeah. Shoot. Of course. Yeah, that's... Yeah, or it'll be the FBI saying, better send us a bunch of gift cards before we come and lock you up. Yeah, it's funny, when I was looking for like an apartment in Charlotte, I found this I found this great deal on like some I don't remember where I found it, but it was like roommate.com or something like that, because I was thinking about getting a roommate. And there was this great deal where this guy's like $500 a month for like this house that's half a kilometer from your workplace. And I call this guy up, and he's got like this thick accent. And I'm like, where the hell is this guy from? And I'm like, hey, can I come look at the place? He's like, oh, I can't. I'm having. Sound like he had like Nigerian accent or something. He's like, oh, I can't. I'm like in surgery for like kidney transplant. And I'm like, okay, that's fucking weird. He's like, send me $500 or send me like a bunch of the first month of payment, and I'll send a courier out to you with the key. And I'm like, yeah, I bet this guy is probably not on the up and up. And so then I gave him some advice about how he could be more convincing in his scam. And he didn't say anything, and he hung up. Why do I not see the chat window anymore? There it is. And I never did get an apartment, sadly. Then COVID happened. Okay. No! Still? What the hell, dude? Am I missing something? That should be right. Why is it not, Oh wait, did I not clear the logs? Yeah, that's the problem. Okay. I was looking at old logs. Ah, okay, we have negative capacity. Yeah. Yeah, that's gonna... Okay. Loading a managed string literal is not supported. Okay, don't know why that's happening. Did I actually try to do that somewhere? I don't know. Well, it looks like it's logging the pertinent figures out. Okay, so not yet full. So when we were not yet full, the tile had a capacity of 180,799. What the fuck? Okay. So... some water was added, but then okay, so current saturation. Where did we calculate you? Current soil moisture divided by capacity. Capacity seemed accurate. Oh, hold on. Yeah, so I guess that's what's throwing me is the negative number there. Like it should be really small. So if our actual moisture is 137 and capacity is 180,799. That's still wrong though. We get a really small number, a really small positive number. This is an even smaller negative number. So why are we coming up with this? It's very simple. When did we log out soil moisture? Right here. I mean, what the fuck? Oh, wait. Wait. I know what's going on. The issue is... soil moisture is being modified quite a bit. So, soil moisture... Before. Soil moisture 1. Soil moisture 2. And soil moisture 3 at the very end. So we'll also go ahead and log out every time soil moisture changes. And we'll see where it gets worked. Yes, okay. So there's 2 times it can change, so we'll grab it before it changes, after it changes the first time, then after it changes the second time. Let's see what we get now. I don't know why this is 1-9. Well, we'll catch the error the second time around. No, I think the issue, Cal, is I think I just had logs from the last time I ran when I hadn't properly substituted the variables in. And so I don't think it's going to happen this time. We'll see. Alright, back to my Copen thingy. Ooh, nice. This is good resolution. Oh, good enough, I guess. Well, or is it? See, that's cool. Ah, this guy. Yes. The resolution's not very good, but it does have all this other handy info. Interesting. The pixelation might drive me absolutely bonkers. Oh, keep looking. Ouch. That's slow. Ouch, that's really slow. What's going on? No, I do see an error. Okay. Error is... Here, I'll give it to you. Getting my logs, though. That doesn't seem like a big deal. So soil moisture is initially 0. Then it's negative. So for some reason we're adding in negative moisture. Who the fuck knows? So it says, hey, we're not full, and then we calculate capacity. Hold on a second. Capacity is calculated up here. It does not change. So, why are we ending up with negative soil moisture after this calculation? Oh, I might know. No, that makes no sense. So, this is what confuses me. We can do... If the soil moisture starts out as 0... all of this is irrelevant. It's going to get multiplied by 0. That 0 is going to be subtracted by 0, and then we're going to end up with 0. So the question is... this. Let's log this out as well. Soil moisture 1.5. Oh, I'll look at that line in a second, Cal. Although I just messed with stuff, so now 160. It was 161. Yeah, okay, so it's this one. Strange thing is it only complains about this guy. It doesn't complain about the other ones. So that's odd. That's clear. Let's run it again. Continue the quest for the perfect Köppen map. I'm not going to find one. Could always just Photoshop in my own header. Oh wait. This one, oh yeah, this one was the good one, but it was granulated. Loading a managed string literal is not supported. And yet... Okay, what is going on here? Maybe clay percents. This makes no sense. 0 is going to multiply into any number to become 0. Right? So what is happening? don't understand. Logging it out the first time, it says that it is 0. I'm so confused. Nowhere, anywhere here do we have soil moisture recalculating. So, I don't know, dude. Yeah. Yeah, I mean, maybe. Let's take a look. But then why would you end up calculating a negative number then? A negative float. So, and I guess there's no way for 0 to possibly be calculated here. It is the only place that the division will occur unless we had 0 material up here, maybe? I guess we'll find out. Sand, silt, clay. Wait a minute. That was the first time around. What the fuck, dude? How is this possible? What the fuck? Okay, soil moisture. Okay, so all of these are legit values. Soil moisture starts out at 0. Let's do the math. Dude, what is going on? Alright, here it goes. .33. 0.34. 0.33. Yeah, but I should just be subtracting a 0 because we're multiplying by 0. See? Wait a minute. Oh no, I know what's wrong. That's wrong. Because I'm only multiplying by 0 for the first factor, and then I'm... Yeah. Okay. Well, at least we got to the bottom of that problem. Yep. Moral of the story is never, ever, ever... Wait. Moral of the story is always doubt your assumptions, right? Something can... Your brain takes shortcuts, right? And will assume that... it's like my brain was imagining parentheses there until I was forced to look really, really close. Moral of the story is also don't work on complicated things too late at night. Because then you will introduce bugs, and then you will have to spend 3 times as much time later fixing them. Now we seem to be getting lots of wonderful errors related to logging. Yay, 0, 0. Calculate capacity, soil moisture. Now we can see. Yeah, and this is, I think it's I think the logs are breaking the burst compiler for this job, and then causing it to go super duper slow. No. No. We still have the same problem. Alright, well, let's check the logs, I guess. See where it finally went off the rail. Oh, I see a bunch of negative numbers. Soil moisture, 138. Current saturation, infiltration, rain in. Move water in. Okay, this is super sandy. Which, yeah, I need to log out. I need to log out current rainfall. Yeah, I'll show you that error. The line that causes it. It's just the first log, I believe. Let's see. 161, right? So it throws that error, and then short circuits, and then none of the other ones throw an error because I'm assuming it like just shuts off the burst compiler or something. So then the other ones don't have the issue. It's, at least as far as I can tell. This isn't a switch statement anyway. Ooh, thanks, Mr. Kobe. We'll look at that when we generate again. Burst doesn't work that way, okay, but it's interesting that it has the error. I think this could be a bug with the compiler because according to the logs, it's supposed to work. Yeah, let me just disable burst for now. Okay, so what was I doing? Oh yeah, I wanted to get the rainfall. No, never mind. Am I not using Unity Engine here? No, I am. It's just saying it's not being used despite it being used. Oh, with the function. rainfall. Is there really anything else we need here? I don't think so. I may have too many windows open. Okay. That's interesting. It's kind of cool, actually. That's really cool, actually. But it's not an American. This map doesn't speak American. It speaks fancy. This map is speaking fancy. Oh, that's interesting. Now it's... Oh, yeah, because I disabled burst. So who knows when the hell it will finish. Okay, so this was the first one. Oops. Clay. What? Weathering alluvial, blah, blah, blah. Sand, silt, clay. I guess we just have shitty rainfall at that moment. Right. Okay. So, So then we drain some away, and that's the remainder. What the? And it says capacity is full, and then capacity gets thrown into negative. Okay, so what's going on here? Like, way negative. What is going on? Sand, silt, clay. This should say rainfall or whatever. And then it says, oh my god, we're full because obviously we have negative capacity. Well, let's... wait a minute. Capacity should be 1. That's not a big deal. Okay, so somehow we... Let's just do math. Yeah, I know my current clayfall. My current rainfall is called clay because... Yeah. Alright, so let's grab our actual... Okay, so in this case, sand percent is 0.83, silt percent is 0.007, clay percent is 0.16. Let's go ahead and do the math here. I was a little bit careless over here. So, go through the logic. Sand percent is in fact over 15%. So, our capacity, which is 1, minus... Wait a minute. No. Okay. I know what's wrong. Yeah, I'll fix that, Cal. It was originally because the float I hadn't been cast to a float. Because Sandsilt and Claire are shorts, if I recall. Let me just one thing at a time. .83. Minus 0.15. .007. Right. Alright, give me a second. I just need to rethink how capacity is going to be calculated because I thought I'd just cheat and my cheating got me in trouble. Alright, so need more water. I think the easy way to approach this is just to assume. Actually, you know what? This could be so much easier. Just yeah. Calculate base capacity using just linear multiplier for each soil, for each texture type. So it really should just be capacity. Let's make it equal to something similar to what we have down here. I feel like long term we need some kind of remediation factor as far as organics are concerned. What are you complaining about? New Copen map. Let's see. Where was the last fancy one? Okay. Ah, cool. Interesting. did I put that little calculation capacity? I don't know. I'm not happy with it, but go with this for now. Leave a note. Long term, we want to revise so that too much clay equals compaction. All right, here we go. Slow down, you got to slow down and take it easy. I really hope it's just burst being disabled that's slowing it down terribly. Alright, well, we'll disable the logs when the problem is fixed, and we'll see if that's the case. Promising. I don't see deserts looking like giant. Yeah, no, not yay. Well. So we have some squirrely glacier stuff going on. What's your excuse? Everything's fine up here with this glacier, but for some reason there's this unusual edge case here. Well, at least we're getting there, I guess. Okay. So we got we got another weird one here. Okay, what's your excuse? More glaciers. What's odd is that big glaciers, totally cool. Small glaciers, and then we had that one instance where glaciers had nothing to do with it. I think this was the case here. Yes. And it's basically a desert, but see what our rainfall and soil looks like. Water level. Okay, so we got a raging river here. Water movement is nan, so somewhere along the line we divided by 0. Sand, silt, clay does not look unusual. In fact, what kind of bedrock do we have here? Just sandstone and acid plutonics, so nothing shocking. Let's check soil no, we know what the soil texture is. So rainfall is, that's interesting. What's the climate here? Sahel. (40 and 37). January water movement. Oh, that's interesting. So January water movement and July water movement are totally fine, but for some reason, water movement, runtime water movement is screwy. Humidity's fine. How odd. Hilliness. No, everything else is fine. Okay. Alright, well, let's grab a tile ID. So clearly what's happening is this corrupted value is being passed down the chain. So looks like it could have kind of started here even. Is this the highest elevation point? Well, who cares? Let's get the ID. 7 3 1 6 7 2. 7 3 1 6 7 2. All right. Start over. Start looking for weird values. Sand, clay, sand, clay. Brute force, fixing elevation, fixing rocks. Calculating water flow. Silt, clay, sand. Looks normal. Rainfall of 41. Soil moisture, that seems normal. Soil moisture, 167, 1657. Normal. Right, so we lost a hefty chunk of it, which is expected. Seems like a lot, though. Yeah, it seems like a lot to lose, but that's a tuning issue. Capacity is 287,733. Soil moisture. It went back up after adding more, I assume. Current saturation is minuscule. Infiltration, rain that went in, water movement that went in, seems right. I would check to see what the water movement map mode looked like, but... Oh, wait, actually... I know how we can get a rough idea, at least. Okay, where was our... Oh, interesting, it got... Ugh. Oh, well, fuck me. What? No! Oh man. It's random. How is it random? Oh, that sucks. Oh no. So because it's random now, I can't search on a specific tile and get a clear answer because it'll be different next time. I think. That's weird though, because there's no random seeds associated here with. This is all very deterministic. Hold on a second. Let's see. Let's try again. Okay, we're gonna try U. Seven, 4, 0, 0, 5, 0. That's unfortunate. 7, 4, 0, 0, 5, 0. Sucks that I'm stuck on this. looks like we did not get the same. Okay, right. It's going to be different every time because I think... How do you check for undefined? I wonder. I think if there's some kind of significant variation in the amount of rainfall that occurs in a tile due to Calandiel's variation algorithms, that would possibly be the reason why we're seeing. But then why? Question then is why wasn't it previously a problem? That's a cool river. But is that no. I wonder where the malfunction is happening. Bet you anything if we turn this off, it's not an issue anymore. Right, but then we never... No, and template should still get passed along. Alright, well, let's see. What? Oh. Right. Oh, but that's weird. I guess... Right, because rainfall gets applied here. Right. Alright, let's find the few places we could expect for a value of 0 that could be divided by something. So capacity? Okay, I know what to do. So let's have a big warning. Capacity equals 0, then we throw an alert. In fact, let's make sure it's not missable. Alright, what other variables can conceivably be divided by 0? Let's look for every time we divide something. Which apparently is like almost never. And there's literally nothing we can divide by 0 other than capacity. So I guess let's check. Anyway, I'm going to probably get up and take a 15-minute break or something just so my brain doesn't get fried. I need my intermission screen back. Let's just see what we get here, and then I'll take my break. Seems like this area especially just this messy place in glaciers. Why are you still logging out infiltration? That's weird. Here, I'm clearing this, I'm starting over. Did I not save? Yeah, I'm only logging out. Whoops. Yeah. Forgot to clear these guys, and they're going to be polluting my logs, so. Anyway, I'm going to mess around with it a little bit more, but I'm going to stop streaming for now. I'll be back a little bit later today. I'll work a little on my own. Alright, see ya.